Hello, everyone. Let's start the webinar today. Our topic is the system for actionable insights from customer feedback called Deep.Listen. We will be showing some slides just to explain the idea of what you are going to see. And then we will illustrate a practical example that you will be able to follow live. I have with me my colleague Sam Montgomery, who is the analyst who actually built the solution. He will be showing it live. So what we're going to talk about is what people can do when they need to analyze their data quickly. So the business challenge is that there is an analytical lag. So frequently you receive more data than you can digest, and you need to run the analysis quickly. For example, you are launching a new product or service, and the customers are flooding your channels with the feedback. You need to analyze it quickly. If you wait too long, the opportunity will be gone. So it typically takes about 3 to 4 weeks to find a good taxonomy that can help you organize tens of thousands of reviews or responses or questions that you receive from customers. And by that time, the product that you launched might be already very difficult to fix any problems that emerged with this product. So the solution would be useful for survey responses as well, for the analysis of support tickets. And our goal is to shrink the time of analysis from several weeks to hopefully several hours. This is of critical importance. And the second issue with the data is that it is not only voluminous, but it is pretty diverse. People can be talking about different topics. And another issue is that you do not know in advance what they're going to bring up. And those issues that are unexpected can hurt you potentially the most, or might be the largest opportunity that you have. So a typical taxonomy that you would be building, this is the structure of hierarchical structure of topics and subtopics that you need to find in your data. It can be measured by thousands of categories. And if you want to do the categorization that you already prepared before, you will be missing newly emerging issues. Also, people tend to use different language to express similar ideas, and it is hard for the system to identify all these. So we need a system that would be able to work with different language patterns, mapping them to the category when people are talking about the similar issue. And I was talking already about the time constraint, so the window of opportunity that you have might be quite limited. And companies that are international, they also have to deal with foreign languages. So the feedback might come in Spanish, it can come in Chinese, it can come in French, and you still have to bring all this data together and analyze it jointly. So what we're going to talk about is our solution Deep.Listen. But before we move there, I would like to show what other things might be important to understand. So when we do manual analysis, we have too much data to analyze, and the promise might be that artificial intelligence, generative AI, can help. There are several problems that you will encounter if you try to load all your data into an LLM and ask it to provide for you insights. First, the context window is too small and the data might not fit there. If you have tens of thousands of feedback data that you need to process, you will not be able to squeeze it in. If you manage to somehow squeeze it by maybe doing sampling or something like that, you can encounter possible hallucinations of the system because LLMs, they tend to invent issues that are not in the data. Their objective is to provide you with some sort of the answer, and they do not announce when they're going to hallucinate. Another problem that you encounter is that the system produces too many categories. As the system encounters new situations, it generates a category. Many of these categories might be quite similar to each other, but the solution will not announce this for you, and you will not be able to work with the results because there will be some explosion in the number of categories that you need to process. And one more issue is that LLMs are not really good at handling hierarchies unless you take some special measures. So as a result, the single LLM still does not help with this task. And this is just one of those tasks that are more complex by their nature. And you need to use multi-agent tools, build solutions that would be applying different LLMs sequentially, let them collaborate with each other, and also provide automation tools so they would support cycles that would be necessary for building the hierarchy of topics and subtopics in the taxonomy, for example, in our case. You also need one language model to check the results of the other. You need to have machine learning tools so you can expand the capability of the solution to identify not just categories of topics, certain topics in your data, but identify which of these topics are key drivers of your target KPI. Because that's what's important for your business. So what we are offering with Deep.Listen is the transformation from a single LLM to a multi-agent system. And this multi-agent system will be performing a sequence of steps. So the analysis steps that we need to go through. So on the input, we have the data that was provided as a feedback to us. And on the, so we have certain constraints, we have certain goals. We want to improve particular KPIs. For example, it can be the improvement of the customer satisfaction. It can be the reduction in time the support agents need to close different tickets that they're receiving for a particular product. It can be the number of likes that the post would be getting on the social media. It can be the sales of the product if you have data, corresponding data available. So, and we need to follow to provide actionable insights that would help us achieve our business goal. So in order to do this, first, Deep.Listen would be auto-generating a taxonomy with the help of this multi-agent solution that we provide. And I will talk in a little bit how exactly it is doing that. The second step would be identifying key categories that in the taxonomy, key topics that are driving the selected KPI. Frequently, you need to use machine learning for that. And if you do not have some parameters you can work off, for example, the rating score for different product reviews, you can use large language models to produce the necessary additional dimensions that you will be able to use later as predictors of the KPI. This way you can determine which categories are important and focus your attention on them. Next, it is very important to keep the human in the loop, because no matter how good is the LLM, it does not know much. It does not know your business setup, business process, and objectives as your employees can. And correspondingly, we need to present the results in an interactive dashboard for the user with some information on which topics are the key drivers of the KPI, and let them judge further which of these topics are of real importance from the business perspective. Once this is done, the user can push the button on a particular category, and the reports from this category are submitted to another agent that generates the textual report with root causes of the identified problems and recommendations. So to dive a little bit deeper, step number one is auto-generation of multi-level taxonomy. And the technology that we're using is called just-in-time taxonomy. Just-in-time means that when the taxonomy can be built on the fly when you need it. For example, if you are a pharma company and you just launched a new drug that is suddenly used by maybe 100 million consumers, these consumers are providing questions, complaints. You need to process this data very quickly. The sooner you can do this, the better, because later the opportunity will be gone. So what this multi-agent engine is doing. So first, it reads every piece of feedback and identifies potential topics. So I was talking about pharmaceutical example. So here we can do a similar analysis for some high-tech manufacturer and, for example, some phone manufacturer. So the system can identify that there are two topics. That there is discharge batteries, there is slow loading. And the system would be doing this for every record in the feedback. Once it sees similar categories, it needs to start grouping them into a taxonomy. If such a category already was present, the system starts counting these. The second LLM is checking the results of the first. It takes the outcome and checks whether discharge battery is actually present in the text of the feedback. So it's solving the opposite task. So gradually the taxonomy starts to be built one category at a time. And soon the taxonomy grows out of proportion, because there are too many individual categories that the system can identify. So next task is doing clustering and grouping together similar topics. So the system can group them together, and one more engine is needed to identify the most relevant topic for the group. So it can take one of the representatives of the candidates in this group, or it can invent a new name for the topics that generalizes them all. And this is done until we process all the records. After that, records are tagged by individual categories that were identified there. And the story does not end here, because we have done this for just the top level in the taxonomy. And frequently, most useful taxonomies are multi-level. So as a rule of thumb, you can do 3 levels. You will be able to capture most of important topics, and yet the system will be able to handle this within hours. If you, with every layer to the taxonomy that you are adding, the calculation time will be increasing, and of course the cost of using LLMs also will be increasing. So once we're done with the first level in the taxonomy, the system now has the hierarchy of topics, and each topic has a bucket of records that belong there. So then the system uses loops to send each of these topics, each of the categories with a corresponding bucket to the beginning of the pipe, and similar analysis repeats. The system needs to decide whether the topics that it identified need to be split any further or not. So once the system runs, performs all the cycles, it typically takes on, say, 10, 50, 100,000 records. It can take between 1 and 2 hours of analysis instead of 3 to 4 weeks. So we can provide the set of topics and use it for categorization of all the data. So all the data has been categorized. So now the next step, as I mentioned, is the extraction of topics that are key drivers of the selected KPI. And here you see this analysis was performed by a semi-government financial institution that provides it generates reports on economies of different countries. And the target KPI here was the popularity of these reports measured by the number of downloads that they are getting. So you see 3 levels of topics in the taxonomy. On the first level, you have 11 topics, on the second 99, on the third close to 1,000. The darker is the color for each of the topics, the more popular this topic is. And you can see that some of the topics, for example, here that are dark, they do not have a large number of reports compared to some governments and public institutions report. Migration and forced displacement has less than 1/10 of number of reports, but they are downloaded far more often. And this is an interactive report. You can review the actual documents that fall into the selected category. So you start clicking on these categories. And one more benefit of using the underlying no-code system for building the solution is that it also supports a strong NLP that allows us to highlight the patterns in the text that caused the specific categorization for the category that we selected. And you can combine it with other tools, so you can drill down by country and so on. So now we have a human verifying the results of the analysis. Once the human clicks on particular categories of interest and pushes the button generate a report, the system provides a report with recommendations. Here you see a report that was generated based on the analysis of retail data. So these were product reviews specifically for granola bars, honey oats granola bars. And the system finds the, so we checked a particular category when people were talking about the bar being rock hard, and at the same time it was dusty when they chew on it. So the system identifies, runs deep analysis of all corresponding records, and it checks the internet, it checks other available sources, checks what it has in its brain to come up with the collection of root causes of these problems and recommendations how to fix them. And I will not be, so technically you can click here and see the corresponding full report. So this report provides meaningful insights, and it provides recommendations what can be the cause and what can be the recommendation for fixing the issue. So it provides detailed recommendations, so the course of action. So the most important thing here is that when we started the analysis, we didn't know where to focus our attention. We didn't know how to split the data into these categories and which categories will be important. So the Deep.Listen solves all these problems and then finalizes it with the report. Who might need to automate these taxonomy generation tasks? It can be people in marketing and sales. It can be help desk, so they can provide rapid response to some critical errors that appear, so you can reduce the customer churn. And you can also work with different survey responses. So it can be surveys from customers, it can be surveys coming from your own employees, or maybe exit surveys of employees. There you can identify key motivators for the department, for your employees. And this system can be used for brand monitoring, because remember, it was looking not only for known issues, but also for something that is emerging, something that you are not aware of as of yet. And Deep.Listen can be doing social listening and identify different critical issues and reputational risks. So we have ran the system on different projects, and the key benefit is that it allows to process data in about 2 hours and get the recommendations on the output. Now I want to introduce a specific use case, and we want to demonstrate how the system works based on the analysis of product reviews. And these product reviews were collected from public sources, and our example is related to a large retail chain, grocery chain. So you see different products presented on the page. In this case, these are different blended juices, and we would be collecting the reviews for these products and analyze them. So you see, in this case, we have some star rating, so this can be our KPI, and we can process the text of the corresponding records. And remember, we need to project everything against our business objectives, because for some of the issues we might encounter certain threats, for example, legal issues. And it doesn't matter in this case how many stars we have, because we need to handle this efficiently. So with this, I want to pass this to Sam. He would be showing us the actual example, how everything works. Are you there, Sam?
Yes, I'm here. Did my share succeed?
Yes, we can see your screen. Thank you.
Great. So this is a report that was produced by our agentic system. It's the result of running the agents on the online reviews from the retailer, specifically on juice reviews. So we can see the categorization that is made up here. You'll notice that some bars are red and some bars are green. A green bar means that it's a positive driver of the star rating. When this tag was applied, generally that the customer was happier, and in fact we have reason to believe that this is a predictive analysis. It's not a mere correlational analysis. So what we did was we actually had a machine learning algorithm try to use these categories to predict the star rating, and the highest ranked green and red bars are showing the categories which drove the star rating most in the upward and downward directions. Well, basically what it's done here is it's taken those categories that the AI found, and it's telling us which of these really matter to your KPI. Which of these should we look at if we're trying to find something that will increase your KPI? So it's uncovering a major issue here. So we see actually within the 100% juice claims category, the top negative drivers are again, no, it's not 100% juice. And here's an interesting one. Confusion between 100% juice and 100% of named fruit. So these are the actual text of the reviews. So to get an idea of what sort of problem it's discovered, and this is a very serious problem, when the problem occurs, the average star rating is 2 compared to 4.8 over the whole data set.
And what does it mean that there is a confusion between 100% juice and 100% of named fruit? Can you provide an example?
Yeah, so how about I just skip to the image. So here's an example of where it occurred. This says 100% juice, lemon juice. So people think that this is in fact 100% lemon juice, but if we look more closely, it says from concentrate with added ingredients. This is an anonymized version, but this is the retailer's product with the name removed.
So the consumer doesn't see the legal statement, the disclosure that the retailer is supposed to put on the bottle.
Yeah, that's correct, and we'll get to that. We're jumping ahead a little bit.
Okay.
But we do have this widespread issue where people feel misled because they believe that they were buying 100% juice, and they were getting something that was not 100% juice. They were added ingredients, or in another case, they were actually blended ingredients. So we can look right here. Most of these affect a single product, though there is a bit of a tail to the distribution. There's a particular product, it's called no sugar added 100% cranberry juice. Reading these reviews, we find, for example, someone says, the #1 ingredient on this list is apple juice, and also I'm allergic to grapes. Drinking this, quotes, cranberry would have been a mistake. So there's an issue going on here. So the next step in the analysis is actually the report generating agent. We take all of these reviews that have been tagged and categorized and identified as important by the previous agents of the chain, and we run them through an AI with a prompt that basically says, read these reviews, tell us what the problem is and how to fix it. And it got us this here deep insight report. And what it found was that there was not only a labeling issue, but that labeling issue was causing a liability risk. There was a product that called itself no sugar added 100% cranberry juice. That was how it was identified on the vendor's website. When if we actually look at a picture of the product, it says 100% juice, cranberry, and I don't know if you can read that or not, but that word up the side says blend. It's a blend
I think
of four juices.
Only lawyers can read this blend. I would not notice it at all.
Yeah, but the lawyers were, I think, not clever enough because they actually are, they didn't do well enough to prevent a liability risk because the customer is being materially deceived by this. Customers are, as you can see, very dissatisfied with their purchase. 1.9 stars out of 5 because they're not getting what they think they're getting. And not only are they dissatisfied, but they're experiencing health issues. As we can see, a customer complained about a grape allergy because they believed that they had purchased pure cranberry juice. We see one reviewer claim that the product cost me my health due to kidney stones once they realized it was not pure cranberry. These blended juices were making the kidney stones worse. Multiple reviewers state that they bought the product specifically for kidney or UTI issues because they were advised to drink 100% cranberry juice from their doctor, and obviously this would not have worked. And less seriously, others just report concerns about the level of sugar from the hidden grape and apple in the juice. So if somebody is materially deceived by your packaging and harmed by your product, you can get in a lot of trouble for that. This AI has put together a 9-page report for management This report was the result of multiple rounds of conversation between the AI and a human in the loop, which would be myself in this case. And we check the claims and get emphasis on what matters. So the question is this packaging legal? The AI thinks no, it's probably not legal. It's a gray area, but there is existing litigation on very similar issues, actually, with the same ocean spray company. And this has tied companies up in court for up to 8 years, it says. So there could be litigation over this, particularly if somebody was injured, as we have reason to believe they were injured, or could have been. So yeah, it says in 2019, Ocean Spray agreed to pay a $5.54 million class action settlement over another deceptive labeling issue. And it's just making the case that this is in fact illegal, and the existing disclaimers on the packaging are not sufficient to absolve the company of liability.
And it's interesting that the system would not know where to look for this issue. It would overlook it if we just load all the data into an LLM and ask it to look for important patterns. So it was of critical importance to create the hierarchical structure of categories first and identify which categories cause the most trouble, and then focus our attention on those only, with human interpretation as well.
Exactly. It's a multi-step process. First, we have to identify what the issues are. Second, separate the important issues from the unimportant issues, and then only third, once we've identified a cluster of records which belongs to an important issue, do we get to generate the report. Otherwise, the signal gets lost in the noise. So a related report that we generated actually from the same data set has to do with a second packaging issue we found. This one was caused specifically by image overlays on the product. And I can show you what that means. We already took a look at this. There's a little new look logo that somebody just overlaid onto the product. And beneath the logo is the essential disclosure material. So this is a little AI-generated image that's been anonymized just to show you what's going on. But if you were to take the logo off, there you would see from concentrate with added ingredients, which legally has to be visible. So whoever put that little logo on the image on the product's website was making a big mistake.
And is this related to one particular product, or this is a systemic issue for the retailer?
It's a systemic issue. We have two example products in this report. We wrote it on the 100% lemon juice and 100% cranberry juice, but this product, this was an issue that occurred on many products across the website. So what we found actually was that this was done by the product syndicator. The website or the retailer did not actually manage their own website or upgrade or upload the images. They had that done by a third-party product syndicator who made this mistake, and so they were very happy to learn that that their syndicator had made a mistake and fixed the issue. And again, yeah, there's liability list from this because you simply have to make these disclosures, and if you fail to make the disclosures, and particularly if there's evidence that the customer is being materially deceived, as there is in this case, by virtue of the star rating and the negative reviews, then that can get you in trouble with the FDA.
Thank you, Sam. My closing points are the following. So first, this Deep.Listen engine is totally universal. So we demonstrated it on a retail example just because we wanted to use some public domain data, but it can equally well work in other domains. It works like magic. You just load the data. In this case, these are anonymized questions from patients that take a particular drug that the pharma company just brought to the market. And you see the system finds completely different set of categories on top level, second, third level. And these are talking about therapeutic use, stability, clinical trials, infection risk, drug interactions, infusion reactions, and so on. And you can apply so you can use the same solution to look at the data in high-tech field. And this is the data from the repair from the support center that performs repairs of laptop computers. And you see very different story. Now, the first level shows hardware issues, network issues, driver issues, spare part inquiry, and so on. And you can apply it in the in some government applications. So this is the result of the analysis of the reports produced by Office of Inspector General with recommendations to fix certain shortcomings of large hospitals across the country. And you can see the main topics are compliance, patient safety, quality of care, and so on. We can depict the results on the map of the United States, showing where the main trouble points are located. So you can go by state, you can see the time evolution and many other things. Also, Deep.Listen is based on AI engines, and it was built, this multi-agent solution was built with the help of the no-code analytical system polyanalyst produced by Megaputer. So we have access to different LLMs from polyanalyst. Some of these solutions use Chat GPT, some are using Anthropic, some can be using DeepSeek. So when Deep.Listen might be useful, so there are different criteria to consider. First, if you need to run the analysis urgently, so we mentioned the example with putting the drug on the market when you get an avalanche of customer feedback. There can be other situations when you also have an avalanche or when your data is changing over time. For example, this can be happening with social media. So then you need to do the analysis for something that you don't know what is happening. So when you need the results faster than in 3-4 weeks, and instead with Deep.Listen, you can get them within a couple hours. If you include a human in the loop, it can take maybe a few days, but not 3-4 weeks. It is important when the content is changing, like with social media, where topics are evolving. So you want to know what new things are brewing there. And it is important to use when you need to just test certain concepts. For example, try to launch a project, you might want to do first the test drive, get feedback, and analyze it before you go full steam. You also can work in uncharted territories, something new markets, innovative products, and familiar customers segments. It can be useful in competitive intelligence projects. And it typically is helpful when you work with average size data sets from several thousand records to 100,000 records. Beyond that, the system might be slowing down because the analysis with LLMs is still time consuming, and you also might be getting taxonomies that become overwhelming if you need to work with many millions of documents. And it is also very useful because it's much more economical than using manual labor. So if you are lacking staff, have tight deadlines or limited budget, this will be a very useful system for you. And one other thing that I want to mention is that Deep.Listen, so far we were discussing the taxonomy that is built completely automatically. The LLM, actually a multi-agent system, comprised of multiple LLMs would be working with minimal human intervention, if any. So human comes in the loop only at the last stage when they try to map the results produced by the automated system into business objectives of the organization. And this is a viable approach when you don't know where to start. But many organizations already have taxonomies that they build capturing topics that are important for them. In this case, you can combine, you can feed these pre-built taxonomies into Deep.Listen, and it will take them into account automatically. It will start the analysis by categorizing documents into your existing taxonomy structure, and then will help you identify which of these categories need to be split further or which categories you are missing altogether. So it can be a hybrid approach. It can be used together with your existing taxonomy. Again, Deep.Listen provides speed, it increases the depth of the analysis, and it allows you to adapt to different situations very quickly. If you are interested, we could propose to start working together, and we'll be glad to carry out a pilot project based on a sample of your data. So say you can send us a sample of 10,000 records and provide the KPI that you would like to work with, you would like to improve. We will show you what taxonomy of topics can be, what topics can be hiding in your data. And we can do this in just a few hours. And then we will specify key drivers of your KPI and can provide reports with recommendations for some most critical topics. So with that, I would like to open the floor to questions. If you have any, please raise your hand, or you can provide it in the chat, and we would be glad to work with you in the future.